In this review problem, we're going to take a look at the antiderivative of the cube root of sine theta times the fifth power of cosine theta d theta. All right, now the technique for this one is that we will peel off an extra power of cosine of theta, noting that I have an odd power of cosine here in cosine of the fifth. So this is the antiderivative of sine of theta to the 1/3 times cosine of theta to the fifth. My first step is that I will split this off as sine of theta to the 1/3 times cosine of theta to the fourth times an extra cosine of theta d theta. Okay, now the next thing that I will do after this is that I will change this cosine of the fourth into sine of theta to the 1/3 times cosine squared theta squared. So 2 times 2 is 4 times cosine of theta d theta. And this cosine squared is equal to 1 minus sine squared. So 1 minus sine squared theta squared times cosine of theta d theta. Now, the reason that I did all of these steps is so that I can do the substitution. U is equal to sine of theta. And so du is equal to cosine of theta d theta. And so by doing all these steps, I can trade this integral for a somewhat easier one. Integral of u to the 1/3 times 1 minus u squared quantity squared du. All right, now for this one, we just simply apply brute force, and we're going to square out what I see here. So integral of u to the 1/3, 1 minus 2u squared plus u to the fourth du. And again, let me multiply out integral of u to the 1/3 minus 2u to the 7/3 plus u to the 13/3 du. All right, now this becomes a fairly straightforward integral to get. So we get 3/4 u to the 4/3 minus 2 times 3/10 u to the 10/3 plus 3/16 u to the 16/3 plus c. And then to finish off the problem, I now resubstitute back in terms of thetas. So u is equal to sine theta. So 3/4 sine theta to the 4/3 minus 3/5 times sine theta to the 10/3 plus 3/16 sine of theta to the 16/3 plus c. And if I were to take the derivative of this, I should end up with this after applying a couple of trigonometric substitutions.